Hello and welcome to this episode of Math with Martinez. We are in our unit on absolute value functions, equations, and inequalities. And the skill that we are learning through this video is how to solve our absolute value inequalities. I wrote inequations. Oh my goodness, that's so funny. I meant to say inequalities. My bad. Let's change that typo. Okay, so we saw previously, while this equation, right, this is the equation that we looked at in our last video, the absolute value of x equaling 3, the way that that is interpreted is x is a real number, 3 units from 0 on the number line. I want to contrast that with this new statement. The absolute value of x greater than 3 describes all the numbers more than 3 units away from the origin. And conversely, if we took the absolute value of x and set it less than 3, that is describing all the numbers less than 3 units away from the origin. And so this first statement is shown here on our number line. And kind of, I think it's helpful to also see here, if you will, with me, let's highlight this. There are kind of two parts here. The portion that is right here and going to the left, let me get a pen so it's a little bit easier to see because it's an open circle. This section here that I'm highlighting in red, these are the values where x is less than -3. That's this portion right here. X less than -3. But also, right, because we're talking about all the numbers that are more than 3 units away from the origin, there is also this portion of numbers on our number line picking up right after 3, where x is greater than 3, these are also solutions because they represent numbers that are greater than 3 units away from the origin. And then what's really fascinating here is to see this example next to it, because next to it we have all the numbers that are less than 3 units away from the origin. And that's going to be this whole area right here on our number line between -3 and 3. That's those values x between -3 and 3. So what we see here is an inequality. We're starting with an inequality statement. We see it graphed, and then we can see how the solution set is described. And I will be looking at us being able to describe it like we have here as one of these two manners. And what are these two manners called? I'm so glad you asked. This first one where we see, let me highlight it in purple. When we have the absolute value of x less than some number, that's going to result in a conjunction like we just saw here. You're going to have this conjunction where it's like an intersection of the two. There's this conjunction. It's this space between two values. But then, if you have this other, let me highlight this differently for us. If you have the absolute value of x is greater than some number c, then what that is going to be is a disjunction. So where a conjunction, like in your study of English, you studied conjunctions, right? They connect something. A disjunction is two things that are separated. Disjunction. And so you can see in the graph that they the two solution regions are separated, where this is a solution region that is combined or joined together. So let's look at one example together here in this video. We are going to solve the absolute value of negative 4x plus 9, that quantity minus 11, greater than or equal to 4. And then we'll graph the solution on the number line below. So first of all, is this a conjunction or a disjunction? Let's pick that up here at the very beginning. Are we working with a conjunction or a disjunction? Well, before we do that, remember that you must always, like we saw previously with the equations, start by isolating your absolute value. Remember we did that here with these? We want to start by isolating that absolute value. Let's do that to begin with. So I'm going to add 11, because sometimes it'll change the direction of your inequality symbol if you're multiplying or dividing. So after that, after adding 11 on both sides, now what we have is a 15. We're saying the absolute value of negative 4x plus 9 is greater than or equal to 15. And so what we have here, it's greater than or equal to, so we're going to be working with a conjunction. With a disjunction. We are going to have a disjunction here. So we need to write our answer. When we write our two separate, we're going to write it as the value inside that expression there. And then it's going to be greater than or equal to 15. So same, right? Exact same. But then the second, when we make this a negative 15, right, to indicate that it is the opposite, right, we need to change the direction of our inequality symbol. So when you set up your two statements, make sure that when you take the opposite solution, that you change your inequality symbol. All right, that's super important. Let me scooch these up a little bit. That was in step number 2, writing our two statements. Then we want to go ahead and start solving. So what are we going to need to do? I'm going to need to, because I'm adding 9, the opposite would be to subtract 9. That's going to give us that negative 4x is greater than or equal to 6. And then we would want to divide by negative 4, divide by negative 4. And that gives me that x is greater than or equal to, and we want to write this as a simplified fraction. So this is going to be 3/2. And over here, we're going to want to subtract 9 again. So this is going to be a negative 15 minus 9. A negative 15 minus 9 is going to be a negative 24. And then we're going to want to, once again, divide by negative 4. Divide by negative 4. And when we divide by negative 4, that gives us x. Whoa, what happens? This is what I wanted us to be really aware of. Remember to reverse the inequality symbol. Oh my goodness, I forgot to do it on the other side. Y'all, oh my god, I even wrote a note to myself and I still forgot. This is so easy to forget. We must, whenever we divide, we have to reverse that inequality sign. And so I should do that right back over here as well. I need to reverse this inequality sign. So, okay, there we go, there we go. I'm so glad I caught my mistake. That happens. I mean, it happened once in my life before that I made a mistake. No, I'm just kidding. We do make these mistakes, but it's so good. It's so good to talk them out together because now we see clearly. And in bold pink, I would encourage you guys to really highlight this, make it obvious that you've got to change the direction of those signs because we divided by a -4. Do you see here? We were dividing by a negative. If you divide or multiply by a negative when solving inequalities, you have to change the direction of that sign. And now we're ready to graph. Now we're ready to graph. Okay, so we've got to set up our graph. Let's see. If I make this 6, then this is 4, this is 2, this is 0. That'll work. -2, -4. All right, so we want to graph our values of x that are greater than or equal to 6. So I put a closed circle at 6, and I shade everything greater than that. All right, and then on the other side, I want at -3/2, which is the same thing as -1.5. So that's about right here, between -1 and -2. I want to include that value. And then I want x values, it's less than that. Okay, so there it is. Our example of a disjunction, right? It's a disjunction, so you can see that here graphed, that it's not this solution set that is together, but it is two separate pieces going in opposite directions that represent this solution region. Ladies and gentlemen, that is actually all that I wanted to show you in this video. It's not a whole lot of new information. It's gonna feel very much like solving just our equations, but when it comes to graphing them, we do have to graph the region as is described by that inequality symbol, everything greater than or everything less than. And the only other big thing to keep in mind are you're going to have one of these two types, a conjunction when you graph it or a disjunction when you graph it. And what you decide that it should be is it should match when you then graph it. If not, you might have made a mistake, and your mistake might have been forgetting to do this little changing of your inequality symbol when you divide. Whew, but I'm glad we caught it before we made that mistake. That's it, you guys. If you have any questions, can you just take a moment right now to share those? And until next time, stay fired up.